Hello everyone, and welcome to this weekly session that we conduct, Ask AuxEn Anything. And as you all know, that this is an online platform for civil structural engineers to interact with us and ask their queries or doubts that they may have related to any project that they are working on, or RCC steel design, or any construction site issues. So this is the 30th such episode that we are conducting, and let's begin with the queries that have been asked. So I'll first take the queries from the Google form, and then we will go to queries asked on email, and then we will go to the live chat. Okay, so let's begin. And the first query that has been asked is from engineer Vineet. He is a working professional, and he is asking. Uh, he's asking this query. Please explain the design approach for band beams and slabs. In many cases, I have observed that no secondary beams are provided and slabs are about 7 to 8 inches thick. The main beam has very low depths while the widths are quite large. Typically, this how is deflection controlled? So I'm not sure what a band beam means. Anyone in the live audience who knows what is the meaning of band beam? Hello? Anyone in the live audience? Band beam, what does it mean? I think what I'm guessing is that maybe the band beam means some sort of beams that are provided as transfer beams or transfer girders, maybe, though I'm not sure about it. So he's talking about some band beams which are having low depths and large spans. How is deflection controlled? I think if these are the spans being used, they must be PT beams and not normal beams. You just investigate. My opinion is that if these types of spans you are seeing in these beams, where for a 30-35 feet span, it is only 18 to 20 inches deep, you investigate whether or not those are PT beams or not. So if those are PT beams, then automatically the deflection is being taken control, or deflection is getting controlled by the PT system. So usually the role of PT system is to mainly take care of the deflections. So that is being taken control with that. That is my opinion. Doesn't making beams wider than the columns risk violating the strong column weak beam principles? No, why it should. In fact, it will help you to satisfy the strong column weak beam, because typically what do we want? That the summation of column should be greater than 1.4 times moment capacity of beams, and in the moment capacity of beam, it will be proportional to BD square. So if I am maintaining low depths, and if I'm making the beam wider, typically what I'm doing, if I increase the depth of the beam, the moment carrying capacity increases by a square of that depth term. And if I increase the width, it only increases by power of 1. So in fact, giving wider beams having smaller depths will in fact help me to control the uh, beam column capacity ratio, isn't it? So yeah. So moment capacity wise, I think giving lesser depth beams having more width will help you to satisfy the moment capacity ratio. But regarding the deflection, if these are the dimensions you have observed, chances are that those beams are PT beams and not normal beams. So PT beams are taking care of the deflection aspect. Yes. So this was my query answer to the query on band beams. Although I'm not 100% sure what a band beam means, but just on the aspect ratio I have tried to answer. Next question is from engineer Sheikh Ahmed Jawad. He is from Bengaluru and he is a working professional. Please explain lift load calculation in depth. So lift loads or elevators. Uh, Let me see if I can find some figures, images. I'm just searching if I can get some good images over here. See, lift load is not lift. It's not very complicated, and it should not be made complicated. It's quite straightforward, I would say. So typically, what happens? I am just taking this image from the internet. This is what your typical lift looks like. Are you able to see this image? Hello. So this is your car, lift car. Let's say this is your lift car, and then these are the hoist. These are the system on which that lift moves up and down, and then this is the lifting pulley system. Okay, this is also called as a machine room because in the machine room this pulley system is going to rest. So lift is nothing but a simple pulley mechanism, and it works on the principle that it sorry, it works on the principle that this pulley is going to lift, and then there is this counterweight which will go down. Simple pulley. This is a pulley in 11th standard we have all studied, and let's say this is a lift car, and then there is a counterweight. So if you want to bring this lift car up, your counterweight goes down, and vice versa. So this is called as the pulley system. So pulley system is installed over here, and then there will be this room which is called as a machine room. So what are the lift loads? So everything is hanging from this pulley. So whatever load of the lift has to be whatever the load of the lift has to be considered as at this pulley level. Now typically what we do, that there are these steel channels if you see. So typically there will be some steel members on top of which this pulley system will rest. So one load that you have to understand first of all is how much is the lift weight. So suppose lift is carrying 4 people or 5 people lift or 8 people lift, whatever. As per that, to that you add the weight of the car, okay, and then you add the weight of the cables. To that you add some factor, impact factor. Okay, so typically that impact factor may be taken to be around 2. That means if your total weight of this lift car plus people in it is, let's say, maybe 1500 kgs, you take the load to be 3000 kgs for your design. Understood? Then you will have this weight of this motor arrangement and pulley arrangement, and plus this lifting weight. So that all weight will be transferred to these steel members, and then these steel members are typically placed on some RCC element or some beam element or whatever RCC system you have created, assuming it's a RCC building. So then that load you can transfer it on the RCC system. Okay, so it's quite easy. And if you see load wise, even if it's 3000 or 4000 kgs, it is what, only 30 to 40 kilonewtons, right? It's only 30 to 40 kilonewtons, which in structural terms is not a very large load, so to say. All right, in structural terms it is not a very large load. So generally the lift loads are not very large, can be easily accommodated and managed. One important thing you should understand, remember, is that don't try to put this directly on your machine room slab, because then this load will act as a point load. So always have some steel girders placed like they have done over here, and then those steel girders should transfer the load to some RCC or whatever other element that you have provided. So never try to have this load directly acting on the machine room bottom slab. So this is a lift which has machine room. Nowadays, you also have lifts which are machine room less. That means there is no separate machine room. Uh, the machine room or the lifting mechanism is accommodated within the hoist system itself. So let me just show you if I find it. So that way, what is the advantage of having a machine room less lift? In lesser space, you can manage your lift, and you don't need a separate space for providing the machine rooms. I'm just seeing if I can get some example of machine room less lift. So these days, you do get these machine room less lifts also. Let me just show you. So again, image taken from the internet. Are you able to see this? So in this machine room less lift, what is happening? That there is no separate machine room less. This is also called as MRL lift. So in this, the lifting system itself is accommodated within this within the hoist system itself. Okay, so there is no separate machine room. The pulley or the lifting device is accommodated in this opening for lift itself. So in such cases, then you will have to see how the load is getting transferred. Mostly that load will be transferred directly to these walls that you have provided across the around the lift. Okay, so typically, if you have provided a RCC wall, there is no need to worry. If you are going to provide four columns, four beams, and in between, if you are providing brick walls, then you need to check and ensure that this load of this pulley at whichever level it has been installed, that is getting safely transferred to your RCC element. Okay. So in machine room less, you will have to study the general arrangement drawing and then decide how or at which location you want to provide these. You need to provide a secondary element for load transfer. Okay. So this was engineer Sheikh Ahmed Jawad asking his question on lift load calculation. It's not difficult. I would say don't make it complicated. It's fairly simple, and the load magnitudes are not very high. Even if it's a 7,000, 8,000 kg load, it's only 70, 80 kilonewtons, which is nothing if you see in terms of structural weights which we designed for. Okay. All right. So let's move on to next question. Mr. Rishabh Thakre is asking, I think, in relation to the earlier question where we had wider beams and less shallow columns, less wide columns. He is asking how is the bar placed in wider beams having width greater than columns. So in this kind of a situation, you can make, if I show it to you in the plan view, let's say this is my column. Okay, this is my column in plan view, and my beam goes like this. As you can see, it's wider than the column. Okay, so this is the beam width and this is the column width. So how do you accommodate this reinforcement? I'll just try to show you it in the sectional view. So in sectional view, how this will look like, uh, maybe what I will do is, so this is my column and I have a wider beam, and of course the column will go like this. So sometimes what we do in such cases, that these bars, as very rightly pointed out by Mr. Rishabh, that these bars will lie outside the column seat. Okay, so these bars are not resting directly, or these bars which you can see outside the column width are not getting a proper seat. So what we do sometimes is that we create some bracket sort of a thing in the column itself internally as a reinforcement arrangement. So maybe I can have two U bars like this. Okay, and these U bars are nothing but some cantilevering bracket. So on these cantilevering brackets, your beam will, and the detailing will depend on the exact dimensions for columns and beams that we have. So although I'm showing the bars like this right now, the accurate representation will be as per the uh, appropriate dimensions that we have for beams and columns. So for these bars which are lying outside the column width, I can have this kind of a seat made out of reinforcement. So this is some reinforcement bracket, and this will help me to support these bars that are outside the column width. In the IS 13920 code, there is a restriction on this. There is a restriction on this beam width, that how much greater it can be than the column width. There is a restriction on that also. So you can have a look at that restriction. It is given in IS 13920. Okay. All right. So this was regarding the beam loads, and so let's move ahead and now go to this question asked by engineer Neeraj Kumar. He is from Gorakhpur and he is a postgraduate student. So he is asking, how can we calculate CPE for curved roof? Mr. Rishabh is continuing. Bracket reinforcement calculation will be same as stirrups. No, so you can also try and find out that approximately the load that will be transferred in this portion of the beam, your this cantilevering reinforcement should be strong enough to take that load. So it is basically acting as a reinforcement bracket, and that bracket you can design for the proportionate load that is in this portion of the beam, which is outside the column seat. So on this portion of the beam, whatever load will be transferred, as per that you can work out these reinforcement brackets and accordingly do the calculation. Okay. Okay. So Mr. Neeraj Kumar is asking, how can we calculate CPE for curved roof? Take example of a 80 cross 100 meter shed. Rise is 3.5 meter on the side of 80 meters. I need proper explanation on it. Arre? So you can refer to, as I told you, I had responded you on the WhatsApp also, that you refer to this 875 part 3. There's a complete table given, and I'll just show you that table. You can follow that table. It is, I think, table number 18, as I can see. Uh, I'll just show that table. So is this table visible? So this is from table 18, and please note this is from the amendment. I am referring to the IS 875 part 3 2015 amendment 1. So this is the figure as per the amendment. So you have this example where you have a 80 cross 100 meter shed. Let's say this is plan view 80, this is 100, and riser is 3.5. So first of all, riser of 3.5 is very, very small for 80 meter. So you should check the geometry. Rise is 3.5 meters. I'm assuming this rise is 3.5. We will need this eaves height also. So eaves height you need to have with you. Let's assume it's 6 meters right now. So how will you work this out? So your example is this, then this is L. So this becomes L. Okay. H is this 6. L is 80. So first of all, you find out the H upon L ratio. As per your H upon L ratio, uh, you can very well see that this is the C2 coefficient, this is the C coefficient, and this is a coefficient 0.4 acting away from the roof. Okay. Remember, this is for this direction of wind, assuming the curve is like this. Assuming the curve is like this. Right now, we are talking about this direction of wind. So this is C2. How will you find? Depending on your H upon L, the C2 coefficients are given. So for a distance of 0.7 h, where h is the riser. So for 0.7 h in this portion, your coefficient will be C2. C2 coefficient. That C2 coefficient you will work out from this table. In this portion, till this h, your coefficient is C. That C coefficient again, on depending on h upon L, will be worked out from here, and then this coefficient is, and then this coefficient is 0.4. So this coefficient remains 0.4 away. So in this manner you will get your coefficients, and of course this is given as plus zero point 0.8 on the walls. So this coefficient is plus 0.8, and this away coefficient is, how much is it? Minus 0.6. What is written? Yeah, minus 0.6. So in this manner you will get your coefficients, and then you can do the calculations. It is further written in the note that when the wind is blowing in the gable direction, CPE may be taken as equal to minus 0.7 for the full width of the roof over a length of L by 2 from the gable ends, and minus 0.5 for the remaining portion. So when the wind is blowing from this direction, when the wind 90 is blowing, the earlier discussion was, let's say, wind 0, when it is blowing in 0 direction, 0 angle, and when it is making a 90-degree angle, what they are saying, that for the first half, so let's say this is 100. So for the first half, first 50, what you will do, you will assume that the coefficient is CPE is minus 0.7 for the full width of the roof. So if this is your shed, whatever, for the full width, your coefficient will be 0.7 acting away. Now what to take for walls, that they have not given. Please note. What coefficient to take for walls, that they have not given. So I'm not sure what coefficient should be taken for walls. So this will be 0.7 for the first 50 meters in the windward direction, and for the remaining 50 meters it will be 0.5 away. Okay. So this is how you will do the calculation. You can read the IS 875 part 3, and you can read the IS 875 part 3 for more explanation, and refer to figure 18, table 18. So it is the table 18 that I have referred to. I hope this is clear now. Okay. So we move to the next question. I'll move to the next question. Mr. Ketan Mahajan, he is a working professional from Jargaon. He is asking, I have sent an image on WhatsApp. Please tell me how to analyze and model this in ETABS. Uh, okay, let me see. Let me see what he has shared on WhatsApp. Where, yeah, so he has put this image. So next question is from engineer Ketan Mahajan. He has provided these images and he is asking about this element from where cantilevers have been taken, if you see. So he wants to know more about these elements from which has been flared up, and then it's a cantilever, and on these cantilevers then the rest of the columns have been taken. If you see this thing, okay. Arre, not able to mark. Yeah, this thing, this cantilever. So in the view it looks something like this, that you have a column, sorry, beam, and something like this flaring has been done, okay, and then it takes it it has been taken as cantilever outside. Let me just draw it. Something like this, and then this cantilever rests, and then you have a column that starts from here, the column at the top, maybe right from the edge. So this becomes the column above, and this you can see is the column below, and this is that bracket that he is talking about. So if his first question is, let me just paste it. What is this question? Please tell me how to analyze and model this in ETABS. Also the reinforcement. No, so in ETABS, see in ETABS, either you make a flared column over here. Actually, this image is not very proper. Let me just make it better, because it's a part of this column itself. It is like this. Yeah. So this is your cantilever sort of beam that has been taken straight, and then this is the column flaring that has been made. So this is a bracket or column has been flared over here. So this flared column, you can model it in ETABS. We have discussed it sometimes before also. Maybe what you can do, that in this you can have a node from here to here, have a node from here to here. In this portion, you give a tapered property. You give a tapered property in ETABS itself. So you will get this flaring, and then you have your regular cantilever beam, or you can have this modeled as a wall element itself. So instead of modeling these columns as line elements, you model them as wall elements, uh, and when you do it as wall elements, then automatically at this region, not automatically, I mean at this region, you do the flaring by creating these wider walls like this. So that is the number two option that you can have. Number one option was adding a node in this region and then modeling it as a tapered property. Second is that you can model it as a wall, RCC wall, and in that wall property, or in that wall modeling, you can have this portion modeled wider. Okay. Detailing, it's just like a simple bracket. So in this region, in this bracket, you need to first see what sort of shears and what sort of flexural moments you are getting. And detailing can be as you do for your normal brackets. So maybe this reinforcement over here can go like this reinforcement straight can go like this, because it has to get curtailed. So after providing certain development length, you can just curtail it. And then this additional bracket reinforcement, after providing the necessary development length, you can have it like this. Additionally, for shear transfers, you may create some bracket arrangement, bracket reinforcements over here, stirrups, which will take the shear forces. So checks, all the checks will be as per your normal brackets, normal cantilevers that you do. Just that the detailing, it has to be done. Uh, I would say keeping or having more caution, you will have to do the detailing. So in this portion, your normal detailing can go. Let me just delete and make the detailing arrangement again. So in this portion, you can have your regular column reinforcement detailing. That is one option. So what I'm saying, in this portion, you have your regular column reinforcement detailing. Then in this portion, you have your bracket type of detailing. You can have a stirrups made and a regular bracket type of arrangement, or or you can add these kinds of reinforcement over here and provide the required development length, and then tie it with stirrups over here in this region, ensuring that whatever stirrups are required for shear transfers, those are provided. In the flared portion, these stirrups will also be important, just like bracket, because these will take the shear forces. So these stirrups are also important in the bracket portion. So you can come up with this kind of detailing, and other checks will remain the same as you have for your normal cantilevers. Okay, all right. So this was Engineer Ketan Mahajan. Then we go to next question from Rishabh Thakre. Can you share your experience in designing? What is he asking? Mr. Rishabh Thakre is from where he's from? He's from Mumbai and he's a working professional. And he is asking, can you share your experience in designing and the most and the challenge you have faced in design of structure or most critical structure designed by you? No, see, every project has its own challenges. It's not fair to say which was more challenging, which was less challenging. So it will be unfair on my part to say it like that. Each project has its own unique challenges, and you get to learn from each of the project. So I cannot, and each project also teaches you different things. Maybe some project will teach you more regarding the design aspect. A particular project may teach us teach you more regarding the construction aspect. So from each project you get different learnings. So it is difficult to pinpoint any one particular project or any one particular challenge as such. Okay. All right. Next question is from Engineer Neeraj. He's from Gorakhpur, and he had asked the question related to the curved roof, wind load calculation on the curved roof earlier. Now he's saying how to design the space truss. Can you please explain on STAD in a proper way? That won't be possible during the live session. So I would recommend you to read first and come up with specific questions. Okay, it will not be possible to discuss complete designing aspects in a live session like this. So you read and you collect your specific doubts and then come back again. Next question is from Engineer Anshuman Adhikari. He is a working professional, independent consultant. He is joining us from Guwahati. He is asking, I had a doubt regarding connection design for a project. I have mailed it. So let me check the email. I'm checking the email. Oh, there are a lot of queries he has put. Wait a minute. Let me just copy all and try to paste it over here. I don't know if it's visible. Hmm? No, I think. Okay, I think I'll have to just bring it image by image. I had to design a skywalk made out of I had to design a skywalk made out of steel connecting two buildings at third floor level. I'm not sure in this which is the skywalk and where are the buildings. Now I analyzed it in ETABS after assigning unbased length factors. Then I modeled the connections ABC as shown. So this is his connection. This is the next image he has put. Then he has put another image. And then he has put another image. Then the girders are also checked in Idea Statica member for the stiffener requirement and buckling factor as safety. Okay. So I have not used myself Idea Statica member, but he has checked these girders in Idea Statica member for the stiffeners required and buckling factor as safety. What is this question? My doubt here is uh, very interesting. He has provided all the information. So he has provided some. Okay, so I think these are his. Okay, what I can understand is that this is one part of his building. I hope this image is visible to everyone. So what I can understand from what he's asking that this is one first. This is let's say the building two, and this is let's say the building one, and these are his. I guess the bridge that he has provided connecting these two sections or buildings. This is his skywalk. This is what I can understand. And these are his girders, let's say girder 1, girder 2, girder 3. And he's calling, wait a minute. Okay, he's calling this as A, this as B, this as C. So, although I'm not sure how he has come up with these support conditions, but let's keep that aside for the time being. So these connections are A, B, and C. Now, what is his doubt? And this is the bending moment diagram for for all of you to see. So at the point B, you can very well observe that due to the continuity effect, even though the support given in the ETABS is pinned, but you will get a hogging moment over here due to continuity effects. At point C, he wants rigidity, so there is a hogging moment. At point A, there is a pin-like connection. So now, what is his A? So I think this is what he has provided at connection A. You can see shear webs provided. Sorry, web cleats provided. So this is supposed to not take any moments. So this blue beam is not supposed to take any movements, and therefore he has provided only web cleats. At this junction, this is the continuity effect where we want. So he has provided it something like this. Now here I have one observation that if you are not, if you are going to provide it like this, ensure that there is no joint that you make over here. So I'm assuming that if you were to make any splices, no splice in this region you will provide. No splice in this region. Okay, understood? So your member should go continued. There should be no splice provided in this region, because if you are going to provide splice, then you will have to be careful, as there will be hogging moment over here. So if you are providing splices, then you will have to ensure that those splice plates or whatever that splice junction has been provided, that is able to take these hogging moments at the connection B. So my first observation is that you don't have any splicing in this B region. If you want to have splicing, you provide it over here when at this inflection point, or at this inflection point, or anywhere in between also, but don't have a splice connection in the region of point B. Then at point C, you will require rigidity. Oh, okay, wait a minute. So this AM2, no, no, wait a minute. I think AM1 is what we need to look at, not. Okay, okay, got it. My mistake. I'll just repeat again. This AM1 is that beam which needs, where we need to provide connection. So this AM1 with this RCC pedestal has been, this has been assumed as a pinned connection. This AM1 with this RCC pedestal is a connection where you are getting continuity effects, and then this AM1 with this RCC pedestal is where you want to have rigidity. So again, the point over here is that if you are going to provide rigidity like this, it will be difficult to control the. Uh, in this, my observation is that it will be difficult for you to control the rotation over here, because this top flange is not tied with this bottom flange and RCC pedestal in any manner. So if you want to have rigidity, I don't think that providing a system like this will be helpful for you. You must have some additional arrangements made whereby you can sort of hold the top flange with the bottom flange. So maybe you can add stiffeners. You can add stiffeners. Those stiffeners should be connected to this bottom plate, to the bottom base plate. Okay, and then you can try to create some rigid connection. But just think about it, that creating a rigid connection between RCC pedestal and beam in this manner will be slightly difficult for you in this, for this sort of configuration. uh, so you must have some proper holding arrangement. So maybe, as I told you, these stiffeners are essential, and those stiffeners should be joined to the bottom plate in some manner. You may have an additional, let's say, top plate like this connected to the top flange, and then in between this top flange and the base plate, you can come up with additional stiffeners. So that sort of arrangement you should provide if you want a rigid connection between this AM1 and RCC pedestal. Okay. Although I'm not sure why you need a rigid connection over here. What is the reason for you to have a rigidity in this region for this connection C? I'm not sure about it. Okay, anyway, his other doubts are my assumptions of support conditions in line with the connection design? So I have given you my opinion about it. You think about them. For the two spans of 4.5 and 14 meters, I have considered a three plate section. This was to limit deflection Is my beam sizing okay? I am unable to comment just by looking at the sizes. It will have to depend on all loads and all other checks. Idea statica member does not even consider the dead load. I assigned the UDL in the beam. However, in the ends, there's a difference in connection C. I have personally not used Idea Statica member software. Mostly, I have used the Idea Statica connection. So, I am unable to comment on what Idea Statica member does. Okay. So, you have a look, you have a relook again. First of all, why you need a rigid connection at point C? Why can't you go with normal pin connections? Because creating a pin connection between a steel beam and RCC pedestal arrangement that you have will be easier. Creating a rigid connection as you want will be difficult. So have a relook. If you want to create a rigid connection, then in this connection C photo that I'm showing you, you need some arrangement to connect the top flange also with the bottom plate. All right. So you think about that also. So these were my replies on the query. I'll just move ahead, and now let me go to another question asked by engineer Prashant Pawar. He is asking this. Wait a minute. He is asking this doubt related to table 6. Engineer Prashant Pawar is asking how to apply the loads for wind in 90-degree. I am unable to understand. No, see, so when the wind is in 0 degrees, when wind is blowing like this is wind 0. So in this region, you will get one set of coefficients. Therefore, if you see EF has been clubbed together, and in this region, you will get one set of wind coefficients. Therefore, GH has been clubbed together. Okay, and so you look for the coefficients. When the wind is blowing in this direction, wind in 0, then this will be, let's say, on faces E and F. This will be the wind on faces G and H, and those values you will get from here. Now when wind is blowing in 90-degree angle, at a 90-degree angle like this, what you need to see, that in this case now the EG and FH will be clubbed. So basically now they are saying that this region will experience one set of wind loads. So now imagine that my wind is blowing perpendicular to the screen. Wind is blowing perpendicular to the screen, and I am in this region over here. I am talking about this initial portion. So here what will happen, that this face will be E, this face will be G, but same wind loads will be blowing on E and G. So those have been clubbed and those have been provided under this EG. And then in this portion, what will happen? So they have been clubbed, and your code is saying that same amount of wind loads will blow on F and H. So therefore, in this column, F and H has been clubbed together. You understand? So this is how you have to look for wind in 90. Also, what will happen? This question is comes to many people, that what will happen in this remaining portion now. So that is not quite clear, and personally what I understand is that you can continue the same sort of wind loads that you are applying on FNH and continue it for the remaining portion also. Okay, so this is how you can apply the wind in 90-degree. All right, so this was engineer Prashant Pawar with his query. So we have finished all the queries in the Google form and on the email. Now let me take some live queries that have been asked in the YouTube comments. So Mr. Hiren Desai is asking, post tension one-way slab they are using wide shallow beams. Okay, so that is the meaning of band beams. Good. Then he is asking how ductility is achieved in post-tension slabs and RCC columns. Post-tension beams and RCC columns. So see, very good. Ductility cannot be achieved with post-tension systems because post-tension systems will work only in one direction. They cannot take cyclic loads. Please remember that the PT system that you are going to install, it cannot take cyclic loads because post-tensioning essentially works when the cable is in tension. Can the cable work in compression? Answer is no. That means it cannot take cyclic loads. So if it cannot take cyclic loads, which are changing its direction, you cannot use the PT system to achieve ductility. So ductility has to be achieved by the reinforcement and concrete itself. Ductility has to be achieved through reinforcement and concrete, not through PT system. So whatever ductility related calculations you do, my understanding is that you don't have to include the PT reinforcement PT system for the ductility based calculations. Understand the PT system as only a system which is going to control your deflection, and that too only the gravity deflection. So for all the rest other effects, you need to still depend on the reinforcement and concrete. Okay. Okay. Mr. Hiran Desai is asking permissible shear stress in concrete, same for normal RCC beam and post tension beam. I don't know because I have never worked on PT systems, so I'm not sure. But it should be, I guess, the tau C max should be same. However, I'm not sure. Any standard details for such wider beams and column junction we already discussed. Does such flaring required on back side of the column? So I think he's asking about this flaring. uh, what Mr. Ketan was asking, that this type of column flaring, do we require on the backside also? I don't think so. It's required. I don't think it's required. Uh, you are sort of thinking backspan sort of a thing, right? So I don't think that is required essentially. Mr. Ajinkya is adding over here, PT tendons have elongation less than 14.5%. Okay, so he's adding this information that PT tendons have an elongation percentage of less than 14.5. Our reinforcement is expected to have an elongation percentage of, I think, 18%. And also, as I told you, PT systems cannot take cyclic loads. They can only take when the loads are tensile. Let's say when the load direction reverses, they will not be able to resist them. So I don't see how PT can be used for taking, or how PT systems can be considered effective in ductility calculations. So PT system should not be used for ductility calculations. All the ductility calculations you should do as per your normal reinforcement provided in beams and columns and concrete cross section. Okay, so I think we have taken up all the questions asked in the Google form and asked on the email and asked in the YouTube live comments. So I guess that's it for this session then. If anyone has any further query, they may just put it quickly on the form. Mr. Chetan Mane is saying, I have a question. I am pasting it in WhatsApp. Okay. Where is your question? I have not received the question till now. I'll just wait couple of minutes. Otherwise, we will take the question in next session. Okay, so I think we will take up the question in next session. And next session, we will start with the Mr. Chetan's question. Okay, on your personal number. Yeah, I have not received any question till now. I have not received any question till now. So we will take it up next session then. We will begin with your question. All right. So all the questions you can continue to put it in the Google form. As I have told you before also, the link for Google form remains the same. Okay, now we have Engineer Chetan's question. Let me see what he's asking. The screenshot is not very clear. I'll just paste it, his query. Wait a minute. This base plate, Engineer Chetan is asking, this base plate is associated with the pad having out of plane 10-degree angle, and Fy and Fx are the forces resolved due to 60-degree pad eye angle. How to calculate moment due to out of plane bending which will cause tension in bolts? This base plate is associated with the pad having out of plane 10-degree angle. Uh, and Fy or Fx are the. I have not understood the question properly. Question is not understood. Maybe if you could share some 3D image or something. This question is not very clear. What your question is? Maybe you can just put some detailed views, and then we can take it up if we have some clarity on the question. Okay. Right. So I think we'll take this question in the next session when we have some more clarity. Right now, I am unable to visualize. So we'll stop over here for this session, and you can continue to paste your queries on the Google form. So the link for Google form remains the same. Every time, once a week, we will take up your questions. So I'm just pasting the Google form link. So I have just pasted the Google form link in the live comments. So same Google form you can use for putting in your queries, and we will reply to them once a week when we meet online in this type of a session. And if you want to get in touch with us over WhatsApp, I'm just putting the link to connect with us on WhatsApp also. So this is the link if you want to connect with us on WhatsApp. So we stop over here for this session. That's all. Thank you. And now we will see you next weekend. Bye bye and have a good time.